Hey everyone, welcome back to Science Facts. Today, we're going to explore one of Earth's most powerful and fascinating natural phenomena, volcanoes. Volcanoes have captured human imagination for thousands of years. Their fiery eruptions can be awe-inspiring, terrifying, and sometimes life-changing. But what exactly causes a volcano to erupt? How do they work beneath the surface? Stick around because by the end of this video, you'll understand the incredible science behind volcanoes. Let's start by traveling deep beneath the Earth's surface. The Earth is made up of several layers, kind of like an onion. The outermost layer is called the crust, and it's what we live on. It's relatively thin compared to what lies beneath it, only about 5 to 70 kilometers thick depending on where you are. Under the crust lies the mantle, a much thicker layer made mostly of solid rock, but not completely solid. The mantle is so hot that parts of it can slowly flow like a very thick liquid over long periods of time. The very center of the Earth is the core, made mostly of iron and nickel, and it's incredibly hot, thousands of degrees Celsius. The heat from the core and the mantle causes convection currents, slow, churning movements in the mantle that drive the movement of the crust above it. This movement of the crust is what we call plate tectonics. Plate tectonics is key to understanding volcanoes. The Earth's crust isn't one solid piece, it's broken into huge slabs called tectonic plates. These plates float on top of the semi-fluid mantle beneath them, and they move very slowly, just a few centimeters a year. Sometimes these plates crash into each other, pull apart, or slide past each other. When they do, they create conditions where magma can form and rise to the surface. But what is magma? Magma is molten rock beneath the Earth's surface. It forms when rocks in the mantle or lower crust melt due to intense heat and pressure changes. Magma is less dense than the solid rock around it, so it wants to move upward. It collects in large underground reservoirs called magma chambers, which can be several kilometers beneath the surface. As more magma accumulates, pressure in the chamber builds up. When that pressure becomes too great, the magma forces its way through cracks and weaknesses in the Earth's crust. This movement of magma toward the surface is what causes a volcanic eruption. When magma escapes onto the surface, it's called lava. The lava flows out, sometimes explosively, sometimes gently depending on its properties. One important factor that influences how violent an eruption will be is the magma's viscosity. That's how thick or runny it is. Magma that's rich in silica, a common mineral, tends to be thick and sticky, causing pressure to build up until it explodes violently. This type of eruption sends ash clouds high into the sky and can produce pyroclastic flows, fast-moving currents of hot gas and volcanic material that can be deadly. On the other hand, magma low in silica is much runnier, flowing easily out of the volcano in lava flows that can cover large areas. Volcanoes themselves come in different shapes, depending on how the magma behaves and how eruptions happen. There are tall, steep volcanoes called stratovolcanoes, like Mount Fuji in Japan or Mount St. Helens in the United States. Helens in the United States. These often produce explosive eruptions. Then there are shield volcanoes like those in Hawaii, which have gentle slopes formed by the steady flow of runny lava. There are also other types like cinder cones and lava domes, each with their own eruption styles and shapes. Another important volcanic feature is volcanic gases. Magma contains dissolved gases like water vapor, carbon dioxide, and sulfur dioxide. As magma rises, pressure decreases, allowing these gases to expand rapidly. This expansion can cause explosive eruptions, blasting ash and gas into the atmosphere. These gases can also affect the environment. Sulfur dioxide, for example, can form acid rain and even temporarily cool the Earth by reflecting sunlight. Volcanoes are found mostly along tectonic plate boundaries. Around 90% of the world's volcanoes are located along the Pacific Ring of Fire, a horseshoe-shaped zone that rims the Pacific Ocean. This is where many tectonic plates meet, making it a hotspot for earthquakes and volcanic activity. But volcanoes don't only happen at plate boundaries. Some form over hotspots, places where plumes of hot mantle rock rise far from plate edges. The Hawaiian Islands are a classic example, formed as the Pacific Plate slowly moves over a hotspot, creating a chain of volcanoes over millions of years. Besides creating spectacular eruptions, volcanoes play an important role in shaping our planet. They build new land, create fertile soils rich in minerals, and even influence the atmosphere and climate over time. Some of Earth's earliest life may have thrived near volcanic vents deep in the ocean. However, volcanoes can also be very dangerous. Eruptions can destroy towns, change landscapes, and cause loss of life. But thanks to advances in geology and monitoring technology, scientists can often predict eruptions by studying seismic activity, gas emissions, and ground deformation, giving communities time to prepare and evacuate. So to sum it all up, volcanoes are Earth's natural vents, where heat and molten rock escape from deep inside our planet to the surface. This happens because of the complex interaction between heat, pressure, the movement of tectonic plates, and the chemistry of molten rock. The result can be anything from slow, mesmerizing lava flows to catastrophic explosions that reshape entire regions. If you want to learn more about specific volcanoes, famous eruptions, or how scientists monitor volcanic activity, let me know in the comments. And if you enjoyed this deep dive into how volcanoes work, please hit the like button, subscribe to the channel, and ring the notification bell so you don't miss out on future science videos. Thanks so much for watching, and I'll see you in the next video.